So, okay, let's do numbers 4 and 5 on this video. These are the two pattern ones, right? Okay, complete the information for the following pattern. When you're on the test, you might have noticed that sometimes you see these patterns and you're like, oh, bada bing, I understand this immediately. It's quadratic, it's 3 times x squared, it's grouped like this, no problems. And then other times you're just like looking at these pictures and you're like, those sure are 3 pictures in a row, but I don't know the pattern, right? So the first thing we're going to do is I'm going to write down everything we can learn without really knowing the pattern, right? Okay, so in purple, it's without knowing the pattern. We're going to count these blocks. There's 3 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. There's 27 here, right? So already we're allowed to plug in. For figure 1, there's 3 blocks. For figure 2, there's 12. And for figure 3, there's 27. That's not a 2. 27, right? Already I can graph some of this. I can say for figure 1, there's 3. For figure 2, there's 12. And for figure 3, there's 27. So already I've gotten all my points for the graph. I've gotten most of my points for the table. And we can see, did we multiply by the same thing twice to get here? No, right? Because this is times 4, and this is not times 4. Because it's not multiplied by the same thing, it's definitely not exponential. Now we're going to see what we added, right? 3 to 12, we add 9. From 12 to 27, we added 15. So we actually also know that it's not linear, right? By looking at the table, we can tell it's not exponential and it's not linear, so it has to be quadratic. So on the test, just fun fact, this is 2 points, this is 1 point, this is 1 point, you missed this point. So you've only missed 1 point out of the 2, 3, 4, 5 point question by not getting the pattern or whatever. Because it's quadratic, we notice that the second difference is always going to be the same. Here we added 6 to get from 9 to 15. So we're going to add 6 again to get to the next growth pattern. So here we added 15. For this one, we're going to add 21 because it's 6 more than 15. And for this one, we're going to add 27 because it's 6 more than 21. So 27 plus 21 is 48. And 48 plus 27 is some number. And that number is 27 plus 15, 75. That makes sense. And now, again, we haven't really figured out the pattern, but because we're doing all this math, because we're doing all this math computation, we can already know the graph, the table, and the type without like having a good gut feeling, right? To get the explicit rule, it's kind of nice to know the gut feeling. Let's talk about it. Here, we can think of this as 3 blocks of 1. We can think of this as 3 blocks of 4. And we can think of this as 3 blocks of 9, right? So this is 3 blocks of 1, this is 3 blocks of 4, and this is 3 blocks of 9. 1 is 1 squared, 4 is 2 squared, and 9 is 3 squared. So it kind of feels like we're doing 3 times whatever number we're on squared. Multiplied. So our explicit rule would be 3x squared, and that's a bonus point. So again, all the stuff in purple up to here is things that we don't really have to understand the pattern intrinsically to be able to do a bunch of math about. And then these last two, we would figure out by knowing that the quadratic grows linearly, so its second difference is going to be the constant one. Now let's do number 5. Scroll. Great. Okay, again, let's do 1, 2, 3, 4. We counted this one. 1, 2, 3, 4, 5, 6, 7. We counted this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We counted this one. We wrote 4, 7, and 10 here. We graphed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to graph it. So 1 goes up to 4, 2 goes up to 7, 2 goes up to 7, 3 goes up to 10. This one goes up to, well, we don't know yet. Nice. We say this isn't multiplied by the same thing, but we are adding 3 both times, so it is linear. It also looks like a straight line, right? If we're adding 3 both times, now we can finish out this pattern and get 13 and 16. We can say 1, 2, 3. That's our 4th point. We can connect these dots if we really want to. And then when we find the pattern, we would say, oh, where would this hit? 2, 3. Here. Where would it hit 0? So we'd go backwards 3 to figure out the y-intercept. And then our explicit function is y equals 3x plus 1. The 3 coming from our slope, and the 1 coming from our y-intercept. That's the bonus point. Okay, let's also do part 6 on this video, and then we'll do 7 in its own video. Find the area and perimeter of the following rectangle. To be honest, this one should remind us a lot of these questions, right? Once we do the setup, the computation we're doing is going to be similar to the binomial multiplication and the distribution. Okay, so the perimeter of a rectangle is the length plus the width plus the length plus the width. Here, the length is x plus 4, and the width is x plus 9. Let's move this over. So the length is x plus 4, and we do it twice. And then the width is x plus 9, and we do it twice, right? And these can be kind of set however we like. All right, so that's 1 point. That's the setup, right? Now we need to simplify. This is when we say, okay, there's 4 x's, and they're being added. So that's 4x. And there's a 4 plus a 4 plus a 9 plus a 9. 9 plus 9 is 18, plus 8 is 26. So this is 4x plus 26 is the perimeter of this rectangle. We can't simplify anymore because these aren't like terms. All right. For the, oh geez, y'all, I get a haircut. Okay, for the area of a rectangle is length times width. Here, x plus 4 times x plus 9. Again, this is a binomial multiplication one. I like the foiling better, but if you want to do the box here, you're totally allowed, where you multiply the x times both of these. X times x is x squared. X times 9 is 9x. And then the 4 times both of them as well, right? So we do 4x plus 36. That doesn't even look like a 3. And now we say that the 9x plus the 4x is 13x. Nothing else is similar. Nothing else is a like term. So we're finished. All right, one more video for the last question, and then the review's done.